My name is Jean-Marc Barrosé. I'm a principal engineer with the SD-WAN technical marketing team at Cisco. And so today we're going to talk about SD-WAN and especially around some of the WAN transformation that we see. So here is the agenda. So we're starting with the what we see on the market, right? Which is a couple of descriptions and transformation that we see when we build enterprise networks. Then we're moving to an improvement we've made over SD-WAN, which is pretty new. I mean, we delivered that back in December, and we call that Hierarchical SD-WAN. So I will go over, what is the goal of this new, I would say, design for SD-WAN. And then we're going over multi-tenancy, which is one of the topic of interest for the service providers. My focus is mostly on the service providers. So multi-tenancy is one of the hot, requires that we have on the market. And then we're moving to observability, which is a term to actually look at the monitoring options that we have on for the SD-WAN overlay. And finally, management, orchestration. It's all about, how do we manage the SD-WAN overlay? How do we configure the SD-WAN overlay? And that's the whole point of SD-WAN, software-defined WAN, right? So let's maybe jump directly into the WAN transformation. So what you see, I've tried to kind of describe what we see on the market, which is a new trend that is shaping up, which is a massive shift of applications to the public cloud. It's actually not really new. We have been working on this for a couple of years, but with the pandemic, it's going even faster. So you see enterprise moving their applications into the cloud, and actually we see different clouds. Usually, you don't want to be locked in a specific cloud provider, right? So we see at least two clouds, and that means because you have multiple clouds, then you have to connect them, and you have to provide a way to access the cloud providers. And this is where you see this so-called middle mile backbone. And that middle mile backbone is really playing a key role in the access to the public cloud, and that provides access to branch users to the applications hosted in the cloud. Now the point is also that when you look at this, the WAN is actually evolving to really a service exchange, and that is where you see this co-locations or POPs. The idea is that we try to minimize the first or last mile, and you actually have to connect your branch office into that co-location or that POP, and within that POP or co-location there is a gateway, and that gateway gives you access to the middle mile, and then you can go to a different site if you really want to have a site-to-site VPNs, or you can go to the applications in the cloud. Right? So this is a new paradigm where we call that meet at the colo, which is the fact that if you want to connect to any service, then the provider is actually going to expose that service edge. So you connect to that service edge, and then you have access to all your applications. And this is interesting to see, because then on top of that, customers and enterprise are actually expecting on-demand services. And this is maybe the biggest change that we see. The fact that we see in the networking something that is very similar to what we see in the cloud providers. I mean, you buy a service, you consume the service, and then when you're done, then you can drop the service. And that creates a bunch of changes, because we are talking on-demand services. So we're talking automation and APIs. And this is something that is extremely important when you look at this service. You want to create the connections, the blue kind of connections between the colos on demand. Then you want to create the connections to the cloud on demand, right? So And SD-WAN is the new envelope for all these services. And so what you see as a gateway is actually an SD-WAN gateway, right? So you have a first connection to that gateway, and then you jump into the cloud, or the middle mile, and then jump into the cloud, right? That is what we see. And then you have all these controllers. One is for the orchestration piece, one is for the route control, right? And the point is now that we actually create the service on demand directly from the management platform that is VManage in the Cisco SD-WAN solution, right? Well, so when you look at this, there is a need to build a kind of two-level topology, right? Nothing new. I mean, when you try to build something which is large scale, then you really want to build that two-level topology. You create regions, and then you connect the regions to the core. Now, what we do, when you want to do that on SD-WAN, what you have to do is to use what we call control plane policies. You define how to connect all the edge devices by defining the tunnels that you want and limit the tunnels within the region. And then you also have to manage the routing updates so that you limit the routes to some regions. Now we can do that in SD-WAN. Right? You can use the control plane policies, but that could be I would not say complex, but maybe painful because there's a lot of stuff to do. Now what we have with this is a new hierarchical SD-WAN, and we introduce a new concept which is the region. So you just define a region ID on your device. And then two, we define a new role, which is this gateway or border routers. And that gateway or border routers is actually giving you access to the core region. So this is I mean, and when you do that, I mean, it's very simple. You just have to give two parameters. One is the region ID, and one is the role. And by default, all devices are edge routers. So normal SD-WAN devices, and you just have to define the role for these devices. Right? And so, along with that, maybe the biggest change is on the route controllers, and we call that in the Cisco SD-WAN we call that VSmarts. Right? We actually define a regional VSmart. So instead of having this big, or this group of VSmart, think about the BGP reflectors. All BGP route reflectors, they're sharing the same routes, and they're connected to all the devices. Now, what we have right now is, if we want to scale, then you can assign a group of VSmart to a specific region. And what is new compared to BGP is these VSmarts are completely isolated. Right, so that's one of the effect of building this two-level topology and the region, because then the group of VSmart for region 1 is completely isolated from the group of VSmart for region 2, and this way you can scale. Now, the fact is, if you look at the left, this is kind of the control plane policies we used to have. To define the policies and to define the topology and to manage the routing updates. Now, as soon as you use HSD-WAN or hierarchical SD-WAN, then it's all gone. You can remove all the control plane policies that we have. So in addition to scaling, we also dramatically simplify. Really, I mean, there's a massive change before and after using hierarchical SD-WAN, right? And along with that, especially for the service providers, right? When you deploy a new customer, you usually have, for large customers, we use a dedicated set of controls. But sometimes, you just want to share for mid-sized customers or low-end customers, then the providers, they actually want to use the same cluster but share the cluster between multiple tenants, between multiple customers. So that's what we have with the controllers. You can just define the amount of tenants that you want to manage inside the same cluster. And along with that, Not we have this control plane that is multi-tenant. Now we are looking at the data plane. One of the options we see, and we see more and more, is especially for the gateways in this new topology, we actually instantiate a virtual function as a gateway in the colo or in the POP. So typically, you see in the colo, you have the typical hardware platforms, but in addition to that, you also have a compute platform running OpenStack or KVM. And then you run or spin up a new virtual function as a gateway. That's one option. But you can also say, well, instead of doing that, maybe I can use a hardware platform, 8500, the Catalyst 8500, ASA1K, and then you kind of split the device into multiple tenants. And you can also say, I'm using a 10 gig link, but I can divide that link into my tenants. So you share the bandwidth, on your link between all the tenants that you have defined on your data plane in your device. Right?
Is this type of division that you're going to do with regard to the resources also going to apply to, so from a configuration standpoint, or is it going to be like the Nexus is that they have a VDC and then you just access a particular segmented piece of software? How is it going to be divided within the router? Because I imagine that somebody can just fat finger something and, oh, I just brought the whole customer down.
Yeah, that's a good question. So we're not using the same concept as the VDC on the Nexus platforms. Think about, we actually divide into two layers. One is the service provider level. And that service provider is actually going to divide and define the tenants. And then inside the tenants, you'll define the VRF, the VRF on the platforms. So it's kind of, it's actually very different from what we have on the Nexus, right? But that's, and the only way you can create the tenant is actually to have the provider role. And that's kind of the upper layer. And then you define the VRF that are part of this tenant. What we see now is the use of virtual functions because maybe it's more flexible. You spin up the VM the way you want, but we have the two options. So that's a choice that has to be made by the provider deploying that solution. And so when we have to monitor that, we have this VManage, which is the configuration platform. It's the single pane of glass for everything that you do in the overlay, right? But then that's also the single pane of glass for the reporting. Right? And so you go to VManage and you have the reporting in terms of the tunnel, performance, the list of applications, the performance of an application. So everything you have, on the VManage. But it's supposed to be, I would say, limited in time. You don't want to store, data forever, right? So, and then we push all the data into a platform which is called VAnalytics, which is a cloud-native, platform. And so when you actually go to VAnalytics, and you can actually cross-launch VAnalytics directly from VManage, and you go into VAnalytics, you have the long-term analysis. You can look at the network performance. You can compare, the MPLS tunnels to the internet tunnels in a specific region. You can look at the application performance overall. We kind of assign a score for the applications. And we also kind of try to do some predictive analysis. Like, this is the trend that you see for that tunnel. So maybe you want to, add more bandwidth on that tunnel because, the way it's being used, then you need more bandwidth. Or maybe you better have to use that pass rather than that pass because it's better in terms of delay. So this kind of analysis.
What's the maximum of data that I can store in VAnalytics? Because there's always a debate whether you would want to have VAnalytics or not. Because VAnalytics allows you to store, at least some time ago, it was about up to a year of data, whereas VManage can store over a week, and then it will be just compressing the older config into an archive and do a rotation of the storage. So is it still up to 1 year of stored data, or is it going to change? Also, is it right now on VAnalytics version 2.5, or is it 2.0? Sorry for all these things that I handle them daily.
That's all good questions. I'm not sure the exact amount of, the time, we keep the data. It's a year, that's for sure. Do we keep more than that? I have to double check and come back to you on this. When you look at VManage, you mentioned a week, it depends, really. I mean, it's, when we export the data from the device into the VManage, it depends on, the size of your disk, pretty much. But you're right. I mean, usually it's a week, depending, the amount of data that we send and the size of, the deployment. VAnalytics, it's a cloud platform, so it's at least a year. But again, I'll come back to you with the exact, time.
Good, thank you.
And then when we look at this, there's something interesting, which is, I talked about the flexible services, the on-demand services from customers, and along with that, when they buy a managed service, what they want is something way more flexible. And this is where we name it co-management. So you have the provider doing the configuration, but then you also want the customer, the enterprise, going into VManage and doing some of the config as well, but not everything, obviously, right? So we have this role-based access control. Again, nothing fancy, but nothing new. But we, in the latest release, 17.6, 20.6, 20.7, we're actually having a way more granular way of controlling. If you look at the policies, for example, you can say, Mr. Customer, you can modify the application-aware policies, but you cannot modify the control plane policies. Or you can read the config, but you cannot modify the config. Right? So we're adding, and trying to be way more granular in terms of, the way we control the access to the overall configuration. By configuration, I mean device config, but also policies. Right? And so this is one of the key requirements we have from a couple of providers to kind of give more flexibility to their service. And along with that, we also have this resource group. The idea is, especially for large scale deployments where you have a lot of a worldwide deployment usually, you usually have also an admin per region. Or a team, in the US, a team for Europe, a team for Asia Pac. And so the point is, now inside VManage, you can actually create a resource group, allocate the devices into the resource group. So, for example, an admin for Europe can only manage the devices that are in the Europe region and cannot access anywhere else. And combined with the airbag control, then there's a great way to actually give some access to the customers, but limit to the device and limit to the features they can actually modify. And this is, this was a really key requirement that we had from the service provider. So that's now available, and we're going to improve that because that's a key point. Again, the flexible services.
Quick question for you, and it's around the co-management and SLAs between customers and their service providers can get pretty tricky with co-management. Does Cisco help out with that in any way at all, or you just offer the functionality and it's up to the legal team and expensive lawyers to figure out SLAs and things like that when it's co-managed?
What do you mean exactly by SLA, Bruno? Do you mean?
Well, if you got a customer able to manage something, some features that the MSP is also managing, there could be finger pointing if there's
right.
Problems caused by a customer, not knowing who caused the problem or the configuration change that caused those problems.
That's a very good point. Actually, I give you an example of what we do, and that's exactly back to your question about SLA. For example, we have a provider that is using this, and he's defining an application-aware policy, right? So he's basically saying, I'm defining the groups, and I'm defining the policy for the group. So for example, I oversimplify, but I have a critical application group, I have a voice video group, and I have a best default, right? And then I'm defining the policies for these groups. And I'm doing that as a provider. But I give my customer the option to allocate the applications to the group. So they cannot modify the policies, but they can assign and say, well, Skype is not critical for me, but WebEx is. So in terms of the SLA, they have the SLA based on the groups and based on the path control that they provide. But inside that group, the customer is able to allocate the applications. So when they come back and say, well, my WebEx is not working properly, then they can actually double check, that WebEx is in the right group. And if yes, then, they have the policies mapped to that group. So that's usually the way they do that for now. They are not completely open the door and let the customer define everything, but they kind of combine inside the same policy. That's why the RBAC becomes very critical, because you really have to go down to pretty much the feature, not just application aware, but inside application aware policy as well.
Yeah, okay, that makes sense to me. It kind of mimics what service providers have when they're offering three levels of QoS on their MPLS network. They offer those 3 levels, and it's up to the customer what gets tagged to get put into those 3 levels. Okay, that makes sense. Thank you.
Yeah, that's exactly the same. Yeah, you see actually the providers moving from IP ports, DSCP to something which is more application based policies, but that's a big change, because they have to redefine the SLA. And to your point, redefine what is an application SLA. It's much harder than, saying my tunnel, I guarantee you will have less than 40 milliseconds of delay. Defining an application SLA is way more challenging. And then finally, the UI and the management. I've been at Cisco for, 24 years. I can't even realize, but we're CCI, right? We're configuring using CLI, so that's not something we can do anymore. So the first point is instead of going device per device and configuring the QoS, configuring application aware and everything like this, we're actually building guided workflow, and that's actually very interesting. So as an example, for the application aware policy, instead of going and defining each piece of that, you actually have a step-by-step workflow. And so I talk about, the group of applications. That's what you get by default. You click on next and you have this group of applications. And then you can change that. You can reassign applications between the groups. And then you go next and you define the path preference. For every group, if you don't care, you let the system decide. And then you come up with, the SLA, what kind of loss, delay, jitter you want for that group of applications. And I skip one step, which is, to define the queue and etc. So we give some defaults. So it's pretty simple, And then, but that's still, policies and device QoS config. Right? Now, what is more interesting is, if you look at what I described, which is access to the cloud and the middlemine config, we have this multi-cloud workflow. You don't want to configure everything, because that becomes pretty complex if you really want to go device per device. Right? So when you go to that workflow, you first define what is your middlemine provider. And for that, we need providers that have APIs, because then VManage will actually leverage the APIs, create the connections, instantiate the virtual gateway, the C8 KV, for example. So if as a customer, you pick the underlay provider that you want. And so today we support Megaport on Equinix. Then you pick the cloud provider you want to use, and you can have multiple providers. You can use Google Cloud, you can use Azure, you can use AWS, and you enter the credentials, and then you go next. And I give you just an example of how do you actually connect a branch office to a gateway, and that gateway is a Catalyst 8000V, right? A virtual function that runs on, in Equinix Colo, in Megaport Colo, or even inside a cloud provider that, you can have that inside Microsoft Azure in V1, you can have inside Google Cloud, you can VPC, you can have this inside the AWS account, right? So, and as you can see, in terms of parameters, it's very easy. You have a minimum list of parameters, and that goes and that configure everything. Then you can always go back to the device and look at the CLI config. It's still there. I mean, I usually get the question, hey, you're going to remove the CLI. Well, no. You can still do a short run and look at the config and troubleshoot using the config. But at least with this, you come up with something which is easy to deploy, and especially if you don't know the internal details of the cloud providers, the transit gateway, the V1 hub, all that stuff. You don't really know, right? So you just follow the guided workflow. And I believe this is interesting. And we're going in that direction. We're really going to add way more workflows. So we're moving away, I would say, from the device-to-device config. We are defining use cases, and then you have the workflows that are mapped to these use cases.
I think I'm going to get back to the granular role-based access control, because I'm getting back to this part of the shared device for several customers. So it means that I can apply even this granular role-based access control, not just to my customers, but also inside my organization, meaning that I can let some engineers handle some particular subconfig or some particular tenant that is configuring this router that is having shared services. Is that right?
That is correct. Yeah.
Perfect.
Yeah. A good example is the security team and the networking team. That's a very common problem. You want to configure the firewall.
Yes.
You see that, right? So
that's a typical discussion. It's like, just don't touch my stuff. But yes.
Yeah, absolutely. Yes.
Thank you very much.